Good morning students, welcome back to chemistry class. Today we are going to study about hydrogen bonding. Hydrogen bonding, very important question. Hydrogen bonding and types of hydrogen bonding. Okay, listen carefully, take notes. Hydrogen bonding. What do you mean by hydrogen bond? Hydrogen bond is a chemical bond between hydrogen atom and electronegative atom. Hydrogen atom and electronegative atom. An example of hydrogen bond is H2O. H2O. For example, H2O means the structure of water. H2O means water. The structure of water means oxygen atom. It combines with the two hydrogen atoms. Okay, this is the water molecule. So the hydrogen bond it is formed between the oxygen and another one hydrogen. Okay, another one hydrogen. Okay, this is the hydrogen bond. Hydrogen bond. So hydrogen bond is formed between the hydrogen atom and the electronegative atom. Here oxygen is one of the electronegative atom. What do you mean by electronegative atom? Electronegative atom means tendency to acquire electrons and forms it forms negative ion when it attracts the electron from the hydrogen and it becomes the electronegative. Okay, it becomes the negative ion. Okay, this is called hydrogen bonds. The hydrogen bond, it is one of the most important natural phenomena occurring in chemical and biological science. Okay, biological science. These interactions play a major role in the structure of protein and DNA. Okay, so hydrogen bonds play an important role in the structure of DNA. Structure of protein and DNA. Okay, protein and DNA. Since they in the case of DNA, the hydrogen bonding hold together the two helical nucleic acid chain. Okay, hold together the two helical nucleic acid chains. Okay, so here when a hydrogen atom is covalently bonded to a highly electronegative atom such as fluorine or oxygen or nitrogen, the bond is polarized. So here, for example, the hydrogen atom, it is the hydrogen bond where the hydrogen bond is formed. It is formed between the hydrogen when it covalently bonded with the fluorine or oxygen or nitrogen. Here hydrogen it is covalently bonded with fluorine. Covalent bond, the bond formed between the two atoms by the mutual sharing of pair of electrons between them. Okay, so here fluorine, atomic number fluorine 9, electronic configuration 2,7. So fluorine, what is the valence of fluorine? 7. So totally 7 electrons are present in the fluorine atom. Totally 7 electron. 1 2 3 4 5 6 and 7. This one electron the fluorine atom share to the hydrogen atom. Hydrogen, atomic number 1, so it share this one electron to the fluorine atom because fluorine need one more electron to get the stable configuration. That's why the hydrogen give this one electron to the fluorine atom. Like that, hydrogen also need one electron to get the stable doublet configuration. So the fluorine atom share this electron to the hydrogen atom to get the stable configuration. Understood? So by the sharing of pair of electrons between the two atoms, the bond is formed. This bond is called the covalent bond. Understood? So when a hydrogen atom is covalently bonded to a highly electronegative atom such as fluorine, oxygen or nitrogen. Here fluorine is the very most high electronegative atom than any other element in the periodic table. The electronegativity arrangement, there is an increasing order of electronegativity. Fluorine is the high electronegativity than oxygen and oxygen is the high electronegativity than nitrogen. Understood? So when hydrogen is covalently bonded to the high electronegative atom, the bond is polarized. Okay, what do you mean by polarized? What do you mean by polar? Polar means Here when hydrogen is the one of the element, when it combines with when it bonded with the highly electronegative atom, the fluorine electronegative atom. So always fluorine electronegative means tendency to acquire electrons to form the negative ion. Okay, so here fluorine, it always attracts the electron towards itself. Understood? So hydrogen atom, so the fluorine, it attracts the electron from the hydrogen atom. So hydrogen, it becomes it partially positive charges developed here, because the electron from the hydrogen atom, it moved towards the fluorine atom. So slightly partially positive charges developed here for the fluorine atom. Like that, fluorine, when it attracts the electron towards itself, slightly negative charges developed here. This is the polar. Okay, suppression of electric charge leading to a molecule. Okay, this is one of the molecule. Here suppression of electric charges developed. This is called polar. Okay. Understood? Due to this effect, the polarized hydrogen atom is able to form a weak electrostatic interaction with another electronegative atom present in the vicinity. Okay, vicinity means nearby, near. Okay, so this is the hydrogen, it is the polarized. Now hydrogen atom polarized. Okay, so this hydrogen atom, it is able to form a weak electrostatic interaction with another electronegative atom present in the vicinity. For example, this is the hydrogen fluoride. Here this hydrogen is polarized now. So when the oxygen, the water molecule present near the hydrogen fluoride means the oxygen, it can oxygen is most electronegative atom. Okay, so the between the oxygen and the hydrogen atom, it can form so one of the interaction takes place. Okay, one of the interaction takes place, electrostatic interaction takes place between the polarized hydrogen and electronegative atom present in the vicinity. Okay, vicinity means nearby. Okay, so the one of the interaction force takes place between the oxygen and the hydrogen atom. So this is due to this interaction, one of the bond is formed. This bond is called as the hydrogen bond. Hydrogen bond. Okay, so the weak electrostatic interaction is not the strong interaction. It is one of the weak interaction. So this is the hydrogen, this is called hydrogen bond. So hydrogen bond is very weak bond when compared to covalent bond. Understood? So this hydrogen bond is denoted by dotted line. Hydrogen bond is denoted by dotted line. Understood? So the hydrogen bond is weaker than covalent bond. Hydrogen bond is weaker than covalent bond, but it is stronger than, important for 1 mark question, hydrogen bond is weaker than covalent bond, but it is stronger than van der Waals force. Van der Waals force. Okay, understood? And then we are going to study about what are the effects on physical properties. What are the effects of hydrogen bond on various physical properties? Okay, the hydrogen bond, it causes various physical properties of an molecule. What are the physical properties? So that is boiling point, vapor pressure, miscibility of liquids. Okay, that is water and methanol. And the surface tension, densities, viscosity, heat of vaporization and fusion, etc. These are the physical property. Hydrogen bond, it causes the various physical properties of the molecules. Okay, about this in detailed manner we will study in our higher classes. Okay, then what are the types of hydrogen bond. What are the types of hydrogen bond? Very, very important. There are two types of hydrogen bond is having. One is intramolecular hydrogen bond, another one is intermolecular hydrogen bond. Very, very important. Intramolecular and intermolecular. What do you mean by intramolecular hydrogen bond? The intramolecular hydrogen bond can occur within a molecule. Hydrogen bonds can occur within a molecule. This is the intramolecular hydrogen bond. Example for the intra means within. Okay, so what example for the intramolecular hydrogen bond? One is orthonitrophenol. Orthonitrophenol. Okay, so this is the structure of orthonitrophenol. OH and NO2. And another one example, salicylaldehyde. Salicylaldehyde structure benzene ring and formaldehyde CHO group and OH group. Okay. So this is the structure of orthonitrophenol. Orthonitrophenol. Okay, actually this is phenol. When NO2 group is present in the ortho position of the hydrogen OH group, that is the orthonitrophenol. And salicylaldehyde, this is the structure of salicylaldehyde. Okay, so here the hydrogen bond is formed between the within the molecule. So for example, orthonitrophenol, the OH group is having here OH group. Okay, OH group. The hydrogen in the OH group, it bonded with the attracts the oxygen in the nitro group. Okay, so the hydrogen in the OH group it form the hydrogen bond between the hydrogen and the oxygen. Okay, hydrogen in the OH group and oxygen in the nitro group. One of the bond is formed. Attraction, weak interaction takes place there. This is hydrogen bonding. Okay, so this is intramolecular. And another one, salicylaldehyde also. The carbon, hydrogen and oxygen and the OH group. Here the interaction takes place, the hydrogen bonding takes place between this oxygen in the CHO group and hydrogen in the OH group. Okay, one of the interaction takes place between the oxygen in the CHO group and hydrogen in the OH group. Okay, so this is called a hydrogen bonding, intramolecular hydrogen bonding. The hydrogen bonds can occur within the molecule, that is called a intramolecular hydrogen bonds. Okay. And then intermolecular hydrogen bond. Intermolecular hydrogen bond is occur between two separate molecules. Two separate, that is like or unlike molecules. Okay. So for example, the intermolecular, inter means between. Inter means between. Okay. So intermolecular hydrogen bond is formed between ammonia molecules themselves, or between water molecules themselves, or between ammonia and water. Okay, ammonia means what is, formula for ammonia, NH3. So between the hydrogen in the ammonia and nitrogen, the another one ammonia form the hydrogen bond, or formed between two water molecules. The oxygen into one of the water molecule and hydrogen in the another one water molecule form the hydrogen bond, or between the ammonia and water molecule, hydrogen in the ammonia and oxygen in the water molecule can form the hydrogen bonding. Okay, so this is the intermolecular hydrogen bonds. Here, one of the two types of atoms are having in the two molecules. Okay, one is the donor atom and another one is the acceptor atom. Okay, here for example the intermolecular hydrogen between ammonia and water. Here ammonia is the donor molecule and water is the acceptor molecule. Okay, because ammonia it donate one hydrogen to the water molecule, so oxygen is the acceptor. Structure of water molecule. Water molecule form strong hydrogen bonds with one another. For example, a water molecule, this is one of the water molecule, it form the hydrogen bond between the another one water molecule. Okay. Okay, this is the structure of water molecule. Here, each water molecule linked to four others through hydrogen bond. Each water molecule linked to four others through hydrogen bond. So here, this is one of the water molecule. Consider this water molecule. It linked with other four hydrogen other four water molecule. Okay, understood? So here the covalent bond, it is the shorter distance in the water molecule, and the hydrogen bond, it is the longer distance in the water molecule. Okay, covalent bond, the oxygen and the two hydrogen atom formed by the covalent bond. This is the covalent bond, it indicates the solid line, and the hydrogen bond, it indicates the dotted line. Okay, so here this is the covalent bond is the shorter distance, means it is 100 picometer, and the hydrogen bond is longer distance, means 180 picometer. Distance between the hydrogen, the two covalent bonded molecule, it is 100 picometer, and distance between the hydrogen bonded molecule, that is the 180 picometer. Understood? These are about the structure of hydrogen bond, structure of water molecule. Then we are going to study about structure of ice. Okay, structure of ice. The structure of water. Water means the oxygen atom, it is surrounded by two hydrogen atom and two lone pairs of electron. Okay, due to this two hydrogen atom and two lone pairs of electron, it is the oxygen atom surrounded by four water molecule. Understood? So this four molecule, it arranged in the structure of ice, means the normal structure of ice, it is hexagonally arrangement. Hexagonally means one of the benzene ring, it is hexagonally. Okay, this what is the shape? It is hexagonal shape. 6 carbon atom having here. Okay, like that in the ice. Okay, formation of ice means it is hexagonally arrangement. Okay, so due to the presence of two hydrogen atom and two lone pairs of electron surrounded by the oxygen atom, it forms the three-dimensional structure. Three-dimensional means two sides hydrogen atom and the back side oxygen lone pairs of electron, and this side also lone pairs of electron. Okay, this is the three-dimensional arrangement. This arrangement creates an open structure. How it arranges the open structure means the structure of ice means this one of the water molecule, it can combined with the another two water molecule by the hydrogen bond, and this hydrogen, it bonded with another one oxygen, Okay, and this also combine with the hydrogen. This is the hexagonally arrangement of the ice. Okay, so here we know this is the vacant space. Okay, so in the structure of ice, it creates this is the three-dimensional shape, three-dimensional structure, and it creates the vacant space. Okay, because of this, ice is lower density compared with water at 0 degree Celsius. Okay, so while in liquid water, the hydrogen bond acquires a long range hydrogen bond in the water molecule. Hydrogen bond is acquired the long range, and the hydrogen bond is strong than the ice. Okay, when comparing ice, the structure of water molecule, the water in liquid state, the hydrogen bond is strong. Okay, it cannot easily dissociate. But in the case of ice means it is easily break down. Okay, so this is the reason for due to the vacant space and the hydrogen bonding. Okay, weak hydrogen bonding, it is the reason for the lower density of ice than water. Understood? So these are about the hydrogen bonding. Very important. So intramolecular hydrogen bonding means hydrogen bond can occur within a molecule. Intermolecular hydrogen bond means hydrogen bond occurs between the two molecules. Okay, understood? Today your assignment. Okay, students, today your assignment, explain the intermolecular hydrogen bonding and state the reason for the ice is lower density than water. Okay, explain intermolecular hydrogen bonding and state the reason why ice is lower density than water. Okay, and okay, if you are having book, take your book now, page number 114. And after I explaining the intermolecular hydrogen bonding, I will mark the book back question answer. Okay, we completed the 4th unit, and tomorrow onwards we have to go to the first lesson. First lesson I didn't take, so I am going to explain the first lesson, and to book back question also sidewise I will give. So today only 7 questions only I will explain. Everyone should write the classwork note. Okay, everyone should write the book back answer in separate note. Everyone should use separate note to write the book back questions, and for writing assignments and the taking notes in YouTube class, that is same note you may follow. Okay, understood? So one side of the page you have to write the assignments, and another side of the note you have to write the notes in the YouTube class. Okay, understood? And for classwork you have to use the separate note. Okay, students? Intermolecular hydrogen bond. Intermolecular hydrogen bonds occur between two separate molecules. They can occur between any numbers of like or unlike molecules as long as hydrogen donors and acceptor are present in position which enable the hydrogen bonding interaction. For example, intermolecular hydrogen bonds can occur between ammonia molecules themselves. Okay, so intermolecular hydrogen bonds can occur between ammonia molecules themselves. So that is ammonia and H3. Okay, so the hydrogen from this ammonia molecule can form the intermolecular hydrogen bond with another one. ammonia molecule. Okay, it can form intermolecular hydrogen bonds can occur between ammonia molecules themselves or between water molecule or between ammonia and water molecule. Okay, hydrogen from the ammonia and oxygen from the water molecule can acquire the intermolecular, this is the hydrogen bonds. Okay, between themselves or between ammonia and water. Okay, the intermolecular hydrogen bonds can occur between ammonia themselves or between water molecule themselves or between ammonia and water. Okay, so water molecule forms strong hydrogen bonds with one another. Okay, hydrogen water molecule, in the case of water molecule, can form strong hydrogen bonds with one another. Strong hydrogen bonds, this is the structure of water molecule. Here the water molecule can form strong hydrogen bonds, strong hydrogen bonds with one another. For example, each water molecule is linked to 4 others through hydrogen bonds. Okay, each water molecule is linked to 4 others. Okay, this is one of the water molecule. It can link to 4 other water molecule. Okay, this water molecule can linked with another 4 water molecule for this one, this one, this one, this one. Okay, so each water molecule is linked to 4 others through hydrogen bonds. Okay, this is one of the hydrogen bonds, another one hydrogen bonds, this another one hydrogen bonds, this another hydrogen bonds. Okay, so each water molecule is linked to 4 others through hydrogen bonds. The shorter distance correspond to covalent bond. Here this is the shorter distance, it corresponds to covalent bond. Okay, covalent bond, you know, this is the covalent bond. So shorter distance, the distance between 2 covalent bonds, that is 100 picometer. The distance is expressed in solid line. This line. Okay, and the longer distance corresponds to hydrogen bonds. This is the longer distance, it corresponds to hydrogen bonds. Okay, so it indicates the dotted line, this is the hydrogen bonds. So here longer distance between the hydrogen bonds, it is 180 picometer. Okay, this is longer distance. Okay, covalent bond, it is a shorter distance, the distance is 100 picometer. The hydrogen bond, it is longer distance, the distance is 180 picometer. Understood? In ice, each atom is surrounded tetrahedrally by 4 water molecules through hydrogen bonds. Okay, so in ice, okay, in the case of ice, each atom is surrounded tetrahedrally. What do you mean tetrahedrally means? So we know this is oxygen atom. It combines with the 2 water molecule, that is the hydrogen atom, to forms the water molecule, and it also has the 2 lone pair. Okay, 2 lone pair of electron. So this hydrogen, it exists in this place, and 1 lone pair exists in this place, and 1 lone pair exists in this like place. Okay, tetrahedrally by 4 water molecule. Okay, so this tetrahedrally by 4, it is surrounded by 4 water molecules through hydrogen bonds. That is, the presence of 2 hydrogen atoms and 2 lone pairs of electron on oxygen atom in each water molecule allows formation of 3-dimensional structure. So it can allow, so 2 hydrogen atoms and 2 oxygen atom having the 2 hydrogen atom and 2 lone pairs of electron. Okay, so in water molecule, in the 2 hydrogen atoms and 2 lone pairs of electron on oxygen atom in each water molecule allow formation of a 3-dimensional structure. Okay, it can form the 3-dimensional structure. This arrangement creates an open structure which accounts for the lower density of ice. compared with water at 0 degree Celsius. Okay, so you know the ice, it is lower density than water. Ice, when we are pouring the ice in water, the ice float in water because ice is lesser density than water, we know. Okay, while in liquid water, unlike ice where hydrogen bonding occurs over a long range, the strong hydrogen bonding prevails only in a short range and therefore the denser packing. Okay, in the case of water molecule, you know, water molecule hydrogen bonding occurs over a long range. Okay, hydrogen bonding, it occurs, it is long range, and covalent bond is short range. Okay, so therefore this is water molecule is the denser packing. Understood? So this is about the intermolecular hydrogen bonding. You see, this is the water molecule structure. This angle between the two hydrogen atoms, 104.5 degree. So here this two lone pairs, and this is one electron that it bonded with the oxygen hydrogen atom, and this one electron bonded with this hydrogen atom. Okay, this is the two hydrogen atom. So for the oxygen atom, two lone pair having and two bond pair having. Okay, this another one. This is the electron for the hydrogen atom. So this is the electron for the hydrogen atom. So these two electrons combine to form a covalent bond. This is the covalent bond. Okay, understood? So this is the hydrogen bridge bonding between the two water molecules. Understood? So, and another, the hydrogen bond occurs are not only in simple molecules but also in complex biomolecules such as proteins, and they are crucial for biological process. Okay, crucial means it is important for biological process. For example, hydrogen bonds play an important role in the structure of deoxyribonucleic acid. Hydrogen bond, it is important. Hydrogen bond is important role, play an important role in the structure of deoxyribonucleic acid, that is DNA, since they hold together the two helical nucleic acid chain. Okay, we know this is the DNA helical strand. Okay, helical structure. Here you know this is adenine guanine and adenine diamine and cytosine guanine. Okay, it's adenine diamine and cytosine guanine. Okay, this two links. Okay, two strand, it is connected by the hydrogen bonds. Okay, you know this is the adenine structure, this is the guanine structure. So it bonded between this diamine hydrogen, this is the hydrogen, white color dot, it is hydrogen, and this is nitrogen atom. So between this hydrogen and nitrogen forms the hydrogen bonding. Okay, and here this oxygen and this is hydrogen, between this oxygen and hydrogen forms the hydrogen bonding. Okay, this is the diamine adenine, and also cytosine guanine, this is cytosine structure, this is the guanine. So between the oxygen and the hydrogen atoms, hydrogen bonding is formed. Between nitrogen and hydrogen atom, hydrogen bonding is formed. Between the hydrogen and oxygen atom, hydrogen bond is formed. Understood? So two this is the two double structure, double layer, but the hydrogen bonds, it is used to hold together two helical nucleic acid chain. Understood? These are about the hydrogen bonding. So you have to mark up to here to here, how to study. Okay, students, now we completed the fourth unit. Now I am going to mark the questions. Totally today only 7 questions. Only 7 questions today I have to I will mark for you. For the one more question, page number 119, one more question, the answer having in the page number 263. You have to refer that. Okay, and the write brief answer to the following questions. Question number 22, explain why hydrogen is not placed with the halogen in the periodic table. Page number 101. Page number 101. Page number 101. Okay. The last paragraph. The left side of the page, last paragraph. Okay, like the formation of halides from halogens, hydrogen also has a tendency to gain one electron to form hydride ion whose electronic configuration is similar to the noble gas helium. Okay, how to write as point wise you have to write. Okay, don't write the paragraph wise. You have to write as the point wise. The point number 1, like the formation of halides from halogen, hydrogen also has a tendency to gain one electron to form hydride ion whose electronic configuration is similar to the noble gas helium. Okay, and the point number 2, however, the electron affinity of hydrogen is much less than that of halogen atoms. Hence, the tendency of hydrogen to form hydride ion is low compared to that of halogens to form the halide ions. Up to here, how to mark. And point number 3, since here to mark, since hydrogen has similarities with the alkali metals as well as the halogens. Okay, and the 5th point, however, in most of each compound, hydrogen exists in +1 oxidation state. And 5th point, therefore, it is reasonable to place the hydrogen in group 1 along with alkali metals as shown in the latest periodic table. Up to here, you have to mark. Okay, point number 1 here to here, point number 2 here to here, point number 3 here to here, point number 4 here to here, point number 5 here to here. Understood? And question number 23. Discuss the 3 types of covalent hydride. Discuss the 3 types of covalent hydride. That is page number 113. Page number 113. Take the right side of the page, the covalent hydride. They are compounds in which hydrogen is attached to another element by sharing of electrons. And the most common examples of covalent hydrides of nonmetals are methane, ammonia, water, and hydrogen chloride. Covalent hydrides are further divided into 3 categories: electron precise, electron deficient. You have to you should write the examples also: CH4, C2H6, SiH4, GeH4. Electron deficient, that is B2H6, and electron rich hydrides, that is ammonia and H3 and H2O. Since most of the covalent hydrides consist of discrete small molecules that have relatively weak intermolecular forces, they are generally gases or volatile liquid. Up to here, I have to mark. And question number 24, predict which of the following hydrides is a gas on a solid: A, HCl, B, sodium hydride. Give your reason. Okay, this is not in your textbook. You have to write in your note. Okay, in classwork you have to write. Answer. Point number 1, sodium hydride NaH is a gas on solid because it consists sodium cations and hydride anions. Okay, so which one is the gas on a solid? Sodium hydride. Understood? At room temperature, HCl is a colorless gas due to the absence of intermolecular hydrogen bonding. The solution of HCl in water is called hydrochloric acid and it is in liquid state. Okay. You have to write in your classwork note. And question number 25 also in note. Write the expected formulas for the hydrides of 4th period elements. What is the trend in the formulas? In what way the first 2 members of the series different from others? Point number 1, the first 2 elements of period 4, KCa, K means potassium, and calcium, form hydrides with the formula MH. MH means metal hydride. K means KH, and MH2, that is calcium hydride, CaH2. Okay, that is the general formula MHN. So where N is the number of valence electron. N is the number of valence electron. Okay, number of valence electron of calcium, that is 2. That's why MH2, CaH2 is formed. And point number 2, elements from scandium to zinc form metallic or interstitial hydrides or non-stoichiometric hydrides which do not follow the law of constant composition. Okay, the elements of the scandium to zinc, it is the non-stoichiometric hydride, so it do not form the law of constant composition. And third point, elements from gallium to bromium in period 4, the general formula, general formula is XHN minus 8 minus N, where N is the number of valence electron. Okay, here this is X means that is, it indicates the metals. Okay, which metals? For example, germanium, arsenic, selenium, bromine. Okay, this X means that is the elements. Okay, elements. And hydride 8 minus N means this the valence. Okay, valence of these elements. Here 8 minus the number of valence. Okay, so germanium, because the germanium arsenic higher valence are having, so we have to take the valence means it 8 minus N. Okay, 8 minus the number of valence electron, we get this. And germanium H4, arsenic H3, H2 selenium, and H3 bromide. Okay. And the question number 16 also in note. Write the chemical equation for the following reaction. Point number 1, reaction of hydrogen with tungsten and oxide on heating. Reaction of hydrate with the tungsten, that is 3H2 plus WO3 gives W plus 3H2. Okay, so the hydrogen reduce the tungsten 6 oxide to tungsten at higher temperature. Point number 2, H2 plus Cl2 gives 2HCl. Here hydrogen reacts with chlorine at room temperature under light to give the hydrogen chloride. Okay. And the question number 27 also in note. Complete the following chemical reaction and classify them into hydrolysis. A, hydrolysis, B, redox, and C, hydration reaction. Number 1, equation number 1, KMnO4 plus H2O2. So KMnO4, H2O2. You know the H2O2 is a strong reducing and oxidizing agent. So H2O2, it is oxidized to the KMnO4 to MnO2 and O2, and it reduced to KOH and water. Okay, so this is a redox and oxidation reaction takes place here. So this reaction is the redox reaction. And the second number 2, chromite chloride. Okay, chromium trichloride plus 6H2O. So here this is the hydration. Hydration means addition of water. Okay, does not undergoing the dissociation, only addition takes place here. So chromium, hexachromium trichloride is formed. Understood? And this is the hydration reaction. Calcium oxide plus H2O gives calcium hydroxide. That is, this reaction is hydrolysis because addition of water, but it dissociates into ions to form calcium hydroxide. So hydration means no dissociation takes place, only addition of water only takes place here. But hydrolysis means there is also addition of water, but water can dissociate into ions to forming ions. Understood? These are the 27th question. And 28th question in page number 112. Hydrogen peroxide can function as an oxidizing agent as well as reducing agent. Substantiate this statement with suitable example. Page number 112. Here you have to mark. Hydrogen peroxide can act both as an oxidizing agent and a reducing agent. Oxidation is usually performed in not acidic, that is basic. Okay, you have to change this. In basic medium, while the reduction reaction are performed in acidic medium. In acidic medium, H2O2 plus 2H plus 2E gives 2H2O. The reduction potential value E0 is equal to plus 1.77 volt. For example, 2FeSO4 plus H2SO4 gives H2O2 gives Fe2SO4 thrice plus 2H2O. In basic condition, HO2 plus OH minus gives O2 plus H2O plus 2E minus. Okay, so reduction potential value plus 0.08 volt. For example, 2KMnO4 in aqueous solution plus 3H2 in aqueous medium to produce 2MnO2 plus 2KOH plus 2H2O plus 3O2 gas. Up to here, you have to mark. Okay, students, everyone should write the classwork note in separate, or use separate note to write the classwork. Okay, and the assignments and the notes in the YouTube class, you have to write in the separate note, and the classwork you have to write in the separate note. Okay, so when you are coming Saturday, you should get correction. Okay, both the assignment and assignment and notes, and also classwork also. Okay, 2 notes are to bring. Understood, students? So today you have to write the this 7 question you have to write. Okay, so this 7 question have to write in a classwork note, and study the assignment also. Okay, thank you, students. Thank you.